Good morning, everyone, and good morning, everyone out there, far away. I am Cameron Rebixol. My presentation, the topic today is Aether, the mother of all forces in nature. And first, please let me introduce you a very down-to-earth experiment. Everybody can verify it. The focal point of the picture is the two styrofoam board and the two styrofoam balls. They both are submerged underneath the water and below the surface of the water, so that their floating is free of the surface tension of the water. If we notice these two styrofoam boards, they are separated at the bottom, but touch each other at the top. It means that there are a pair of forces pushing these boards together. That they are close to each other at the top is not because any attractive force, but because of some pushing force. Same here is the styrofoam balls. These are the two weights hanging below the ball, so that this combination can be regarded as a floating object with the minimum floating force. So these two balls also touch each other. Even after you push them away, they will slowly drifting back to touch each other. On this, I showed the dimension of the ball. This is the wrench socket, and with this dimension, the ball has the dimension of this from center to center is 2 and 15/16. It means that if this ball are floating straight, absolutely straight upward, they should be separated by 1/8 a tenth an inch, but they don't. In the water, they have to touch each other. Attractive force is hardly to be established by anything. So I conclude that must be some pushing force from both sides, outside of the ball, and push them together. So if this is a ball, outside the ball is some liquid, some fluid. We have two hypothetical sphere concentric with this ball. The calculation shows that the force of the inner sphere and the surface of the outer sphere, they must push each other with equal force, so that these two hypothetical sphere cannot move anywhere with respect to the center of this ball. With this relationship, we establish the pressure on these two sphere has this relationship. Inversely, put this proportion to the radius of these two balls. So the fluid pushing this hypothetical sphere must have volume and shape. At this point, I don't know how exactly what shape it is. So I just imagine that they may arrange in this several ways. Number one, loosely, okay? and the ball may or may not touch each other. The second arrangement is the ball may compactly touching each other. However, they arrange in cube, in a cube style. And on this one, the balls has immediate contact with all the neighbors, and any of the four can occupy the vertex of tetrahedron. And indeed, between any three balls, and you can put another ball in between, so that it will touch another three. And this arrangement can extend infinitely. But as far as the compactness is concerned, this arrangement has the highest compactness. No matter what pressure you can apply to squeeze them, they cannot come any closer. I think that's at the maximum compactness. But for this, some balls may shift slightly, okay, and still use more space for other balls to move around, but this cannot. There is another geometrical rule we need to notice. If we cover a volume, a big volume, with smaller volume object, the covering cannot be perfect. Somewhere there must be some gap left between those small objects. Okay? And this kind of gap can leave some space for the small volume to move around. So now I imagine in the fluid, I blow up a ball from 0 to this volume, and immediately next to the ball that's on the surface, there may be a region. The particles are compact with the highest compactness. And gradually, out there, it gets released. They do not distribute themselves in band like what this is indicated. They just slowly, gradually relax. The reason you see bands here is because the limitation of my drawing skill and my drawing tool. But it should be gradually, smoothly, smooth out. In other words, this area is the most compactness, but out there it is less compact. Now, we can also imagine there's another ball like what we see up here. However, this ball is incomplete because inside there's another two truly empty balls here. So immediately next to this ball, we have a very compacted arrangement of the particle, the fluid particles. But on the other side, the particle, the compactness gradually reduced with respect to two balls. The center C has the lowest compactness. But then, if we have a ball exactly as this, the radius exactly as at the surface of this small ball, and we have this hypothetical ball, And the calculation can easily show that at this point, you don't have the highest compactness of the fluid particles. The compactness here, or the density here, is lower than this point, of course. And from this point on, the compactness or the density of the fluid gradually go lower and lower up here. Between all those points, this point has the lowest density. Maybe this and this point, K point and A point, has the same lowest density. And point M and point L has the highest. Because the density difference that you create a potential for those particles gradually migrate from higher density to lower density. That will create a potential to push that point, the ball Q and ball J going slowly together. However, this is only qualitatively analyzed that way. In the next, next we are going to quantitatively analyze it. I introduced the equations a few slides ago. Okay. Compared to this diagram, we go to this diagram, and then we can have this relationship. A constant force are pushing between the inner sphere and the outer sphere. If I blow a ball from zero volume to a certain radius, and then I can have this constant force just simply time the ball's increasing radius. If we make the R1 as 0, we simply have FR2 as the energy required to blow the ball, to create the ball. Now we repeat the diagram here, okay? Except that making one is smaller than the other. So here's the other two balls, and I magnify this area to this bigger picture. And this bigger picture, D, the big D is the distance from the center of this smaller ball to the center of the bigger ball, R1. And also we can see that this the big circle of this smaller ball cut off a crown A, B, C from the bigger circle. This bigger sphere is radius D plus H. Okay. Between the D plus H and the D plus R2, they should have force pushing each other and stay equilibrium, don't move anywhere. However, the smaller ball R2 cut off the crown A, B, C. In other words, when the smaller ball with radial d plus h want to push out against the squeezing force from this smaller, this bigger sphere, d plus r2, it has a force deficit. It could not apply the equal force push back. Whatever the outer force here apply on this bigger sphere has slightly bigger force to push this sphere. This sphere has d plus h as a radius. So calculation shows that the force applied at d plus h, this sphere, pushing out has that much of deficiency. Okay. This term PR1 is the pressure at this ball, because we have to establish a relationship. What is the pressure applying to this ball, d plus h? We need the pressure as a reference from this ball. Okay? This ball has the pressure of this value. It has also some relationship with the general intrinsic pressure of the liquid or the fluid. So there is the difference between the force squeezing in on this sphere and the pressure, the force pushing out to the resistant squeezing force from this sphere, totally net out that much of force. It is with this force, the pressure, the fluid pressure on the d plus r2 can constantly squeeze in and push the ball approaching this ball. That's the F, the net force. And it has the relationship with the inverse relationship of d squared. It means that the further this ball is far away from R1, that force is reduced. The closer it comes to the R1, the force increased. If we fill this ball with solid material of mass density of D, with the we can easily calculate how much mass this R2 can contain as mass, and how much mass this ball contains. Convert to the mass density and the corresponding mass. We can have this, the same equation written as this, in this form. Okay? So this form is very closely matching what Newton's gravitational force equation. Okay? That's the M from this ball, M2 from this ball, and D squared is the distance between these two balls. So this part looks like a gravitational constant. But then we have question What the PR1 means, because it's unknown now. We can only know it is related to the intrinsic pressure, the overall pressure of the fluid. Let me skip this and come back to it later. Okay, in order to get the PR1, we need the help or the binding energy of the in the nuclear physics. And I choose the alpha particle, the binding energy of the alpha particle to calculate the PR1. I assume the alpha particle is a ball formed by several nucleons. To break the alpha particle, I have to supply energy to break them. So whatever the energy can be applied to break apart the alpha particle, I will consider that can be used as a magnitude for calculate the PR1. So with that kinetic energy, the binding energy, I get to this value. You can tell that there's a very high value of pressure, 10 to the 22 power. But that is in the microscopic dimension. We calculated for between the atoms as the liquid or solid, the distance between those atoms normally is in this scale, 10 to the minus 10 power meter. As gas, usually the distance between the particle, the atoms, are 10 to the minus meter. In other words, if we go to this distance, the intrinsic pressure of the fluid, the ether fluid, cannot have high volume to squeeze to draw those atoms together. So I applied this distance, and also the distance between the alpha particle nucleons, and finally come back to this value. This value means the pressure between any two small particles, the atom or nucleon, if they are separate at this distance, okay, the pressure at this distance will be 10 to the 12 kilograms per centimeter square. That's the intrinsic pressure of the ether as a fluid. It is the fluid pressure that squeezes the atom together and also squeeze the nucleon together, but at a very short distance. Like, for example, for the nucleus, it is 10 to the minus 15 meter. So, yeah, in other words, in our environment, we always encounter a fluid that has intrinsic pressure of this value, 10 to the 12 power kilogram per centimeter square. However, we don't feel it because number one, we get used to it, Number two, the ether fluid permeated in every all this space in the particle that form our human body. And we still remember that we are at primary school or middle school, we are told that there is an air pressure of 1 kilogram per centimeter square applying our skin. We get a surprise. How come we don't feel it? It's because we get used to it already. Same to this situation. And we get used to it, number one. Number two, the ether fluid already infiltrated or permeated in every atom that form us. Without that intrinsic pressure of fluid, there's no human being, there's no life form. Every particle that become meaningless. Nothing they put them together. On this picture, I just mean that suppose this is the sun, this is the earth. All those small bubbles are actually the nucleons that the proton, the neutron, or electron put together. In between all those subparticles, the nucleons, there are still space. They don't. All those nucleons do not come to skin touch between each other. They just come very close because of the intrinsic pressure of the ether. Suppose this is the Earth, same thing. Okay. So the force between this and this are actually the sum of the force of all those nucleons force come together. Whatever they can feel from the ether. Okay? That's how they are put together and feel each other as a gravitational force. So when the Earth moves around the sun, this gravitational force instantly is established because the pressure of the ether is always there. And there's no information needed to transmit between the sun or the earth. And otherwise, each of the gravitational body must feel that how much mass do you have? And then I would act accordingly. No, there's no such thing, because the ether pressure, the ether fluid is all over in the space, and wherever it moves, the relationship is immediately there already. Okay. By the way, because of the insanely high pressure of the ether fluid, to attain this fluid in the universe has to be infinitely large. There's no container that we know of can hold the ether together. So in order that for the ether has no way to escape to anywhere, this universe has to be infinite. And to me, Hubble's law is an evidence that to prove that the universe is infinite. I have a paper for that quite a few years ago, but by that time seems no other evidence to prove that universe to be infinite. But now the gravitational force needs a high pressure fluid to establish. And that high pressure fluid needs an infinite universe to hold it. So I believe Hubble's law and this either fluid of high pressure are supporting each other. So today that's all I say on this matter. And if there's any question, please ask me. Thank you very much. Yes, sir.
Please hold it in front of you like this and state your name.
Bob Lavacci.
Hi, Bob.
In the very first image that you showed us, with the two bars that were touching on the top, but not on the bottom.
Yeah.
Could you explain again what attributes that they're touching on the top and the bottom? Well,
Okay.
what's your whole lecture explaining that?
Okay. First of all, I need okay. I need to say the two boards, the styrofoam, the floating force is extremely strong. At the beginning, I think I could weigh it down with a brake. No, it pulled right up. And then I add the crowbar there, it still pulled the whole thing right up. So I have to use a sledgehammer to weight it. And if there's no pushing force to push the two boards together, these two boards should stay parallel to each other. Right?
Yes.
Yeah. But because of some pushing force from outside, and these two boards will touch each other. At the bottom, the floating force is very strong. Okay, the vertical force dominates. The pushing force cannot dominate. But gradually, going higher and higher, the floating force is less dominated. The pushing force is getting stronger in the proportion. Yeah, and then push the two boards together. And obviously, we cannot establish an attractive force between the two boards. So I have to owe this phenomena to the pushing force from the liquid.
I understand. You answered my question.
Thank you, sir.
Okay, we have some questions from
Yeah.
our live stream from Slobodan. He's got two questions.
Yeah.
Can there be something at all something as universal gravitation constant as is the case with mainstream science? That's question one. And question two, would there be an indication in your analysis that the ether pressure can actually be as high as 10 to the 36 Newton meters squared?
Okay.
The first is on universal constant.
You mean the gravitational constant?
Yeah, universal gravitational constant.
Okay. This is what I have similar to the gravitational constant. However, when we go to the nuclear particle part, this should be refined to another figure. On the other hand, this is a very crude analysis over here, and there should be some other factor affecting the value of this constant. And as Bill Lucas pointed out, and his lab measured the gravitational constant, and then it changed all the time and fluctuated. And to me, I believe what he said. However, there should be an intrinsic value for the ether. On the other hand, because the ether fluid is so gigantic, occupying the entire universe, I'm not surprised that from time to time, some fluid wave of fluid density can drift and move around without our awareness. Okay, indeed, if this is the value we get, that intrinsic pressure value we get with the ether fluid, if we change the value to 10 to 11 power or 10 to 13 power, I'm not sure we can detect it with our personal feeling. However, when the fluid is so waving, the gravitational constant will change. That's for sure. And as to how fast the fluid can move, I don't know. But with the physical possibility that it may move, I'm not surprised that the constant value may change time to time. However, there must be a natural value for that. Just like me, okay, I'm that high, but in the morning and in the evening they measure there's a slight difference on the high. So I'm not surprised on that. But there should be a nominal high for me to be referred to. That answer the question? Did I answer the question? Okay.
This ether you are talking about, does it uniformly fill the whole of infinite space?
Infinite space and any small space, like the space between the proton and the neutron and the electron inside our body. You find that too. Yeah.
And in the whole of infinite
and the whole universe too.
Uniformly.
Okay. Suppose that uniformly, but there's so many mechanical things going on, so there may be some wave, okay, moving without our awareness.
Okay.
Because the pressure is so insanely high, 10 or 12 power. As a matter of fact, when we go to nuclear force, it should be even few thousand times stronger than this value.
Okay.
Yeah.
Okay. My second question is, you said the ether has intrinsic pressure. Does it have intrinsic density?
Yes. But the intrinsic density vary from the distance from the smallest particle. For example, if this is a neutron, okay, and immediately to the surface, the neutron, it has a certain value of density. That's the most compact layer. No matter what force you squeeze, the density of the ether particle there will not change. You can increase the pressure, but you cannot increase the density. But gradually, some distance away from the surface, the density begin to reduce. In the more detailed calculation in my paper, I believe from this density, the surface density, to far away, the change may be about 10%. You cannot go lower than that. Yes.
In your calculation you're showing on the screen there, what did the value of G turn out to be?
I dare not go into that detail. So because the reason is, number one, I'm not a scientist. I don't have all the equipment to test. Number two, indeed, on this is a simple version. Later on, there will be some. Okay, the ether particle in my version include at least 3 more elementary particles. Then one particle is sensitive to negative charge. Another particle is sensitive to positive charge. Another particle is called neutrino. So before I can really determine decomposition, I cannot go to that calculation and mislead other people. But there is something contributed to the gravitational constant, that's for sure.
No more other questions? Okay, thank you very much.
Thank you.